Welcome to Module 6, Lesson 17, Slicing a Right Rectangular Pyramid with a Plane. Okay, so the difference this time, difference between this lesson and Lesson 16 that we just did, is that we are now looking at a right rectangular pyramid instead of a prism. Okay, so very different in ways, but the slices we will make will still be perpendicular and parallel to the base, okay? Because that base of the right rectangular pyramid is the one that is actually a little bit easier to work with, of course, because it is, in a sense, it is flat, okay? You guys have had some experience with pyramids in Module 3, about Lesson 22, but then we were looking in the context of surface area, if you remember that. This lesson here, Lesson 17, will give you guys the opportunity to build some pyramids from nets as you study the formal definition of pyramid. Okay, now those nets, I have posted these at the website. So they are in topic C, right before the Lesson 17 recording here, and you probably saw it when you were there opening this one up. You'll see that you'll have these two templates. If you'd like to click on those, you can, and then you can print those out and create your pyramids using those nets, okay? Kind of make it make a little bit more sense, probably. Okay. Okay, if you would, it'd be great if you could go ahead and print out one of those right rectangular pyramids, or maybe both, and go ahead and fold on the dotted lines. And I'm just taking an example from elsewhere, just to make some points about a pyramid, okay? Very, very important, some important points. If you look at the pyramid, you look at the one that's been built here, okay? This one right here that's been built from this net right here. If you take a look at that, or if you take a look at yours, again, maybe tape the sides so it stays upright, okay? How would you describe a pyramid? What are some of the descriptions of a pyramid that make it very special? Okay. Well, number one, okay, in this sense here, is that it has a rectangular base. Okay, and here is that rectangular base right there. Okay, and again, in this sense, so this one here looks like it's a square. One of yours, actually, one of the templates has a square as a base, and the other one is more or less a rectangle, but a square, of course, is indeed a rectangle as well. Okay, so that's one thing. You got the rectangular base. The sides, okay, so the sides here, and then when you build it right here, here are sides, okay, all of those are what are called isosceles triangles, okay, and again, we've talked about isosceles triangles before, not in any kind of depth, but isosceles triangles, if you look it up, there are always two sides that are equal. Okay, those two sides are equal. It's not necessarily an equilateral triangle. Okay, because an equilateral triangle they will all be even. Okay, in this case we don't know. Honestly, I'm not sure about this one here, but yeah. So they are what's called isosceles triangles, and all of those, the edges of all of those, meet at one singular vertex, okay, which is right there. Okay, so right at the tip there, that is one point where all of these sides meet. Okay, and when this gets together with this and this and this, they all create one point. Okay, so that's those are a few things that are very special about a pyramid. Okay, and if we move ahead here, we have a bit of a formal definition of a rectangular pyramid. Okay, it always starts off with statements like given a rectangular region, blah blah blah. Okay, which is formal and which is which is real and which is used, but it's a little bit more confusing than what we just did, I think, when you look at your prism yourself. But anyway, given a rectangular region B in a plane E, okay, and that's right here. If you see our little rectangular region here, here's rectangular region B, and it is sitting inside this larger rectangular region here called E, and point V not in E. The rectangular pyramid with base B and vertex V is the collection of all segments VP for any point P in B. Okay, boy, that's woohoo. It can be shown that the planar region defined by a side of the base B and the vertex V is a triangular region called a lateral face. Boy, that is a definition that, whoa, that is one heck of a definition, huh? Well, anyway, yeah, that definition is quite confusing. Confusing to us, especially you guys, just learning this type of these. Well, you've known about these for a long time, but just to learn about them more formally. Okay, so right here we could just look at it step by step. They've laid this out actually quite nicely for us. A rectangular region B in plane E and point V not in E. Okay, so in the sense that we're looking at E as being a plane. Okay, so again, just imagine that this extends that way, it extends that way, it extends that way, it extends that way, that way. Okay, I mean it's just going to go on and on. This is a section of it. Okay. But in that plane, okay, this point V is not in that plane, okay? It's not in that plane, it's above it. It's in actually a different plane, a plane that exists above, another flat planar region that sits above, in this case, this plane E, okay? Now we have a rectangular region, okay, which actually sits in this plane E. Okay, so it sits in there, and it is connected to V. Okay, we can connect it at any segment that connects it to this this rectangular region B. Okay, and you can see we can just connect it at all different places, different points. Okay, and you can see that right here. The rectangular pyramid will be determined by the collection of all segments VP for any point P in B. Okay, VP is shown for a total of 10 points in this case. Okay, and you can see, again, we could just keep drawing different points, and they have to extend from V, and we say P, but P is just any point. We haven't actually designated a specific point for all of these down here, for any point P. Okay, and again, they're not only around the outside, but they're also in here as well, okay, on that plane, I'm sorry, not plane, but that rectangular region B, okay? So down here it says the rectangular pyramid is a solid once the collection of all segments VP for any point P and B are taken. The pyramid has a total of 5 faces, 4 lateral faces, and a base, okay? So you can see our lateral faces are this. There's one. Here's a second. And the other one, well, let's just move those two. And then you can see the other one over here. That's our third. And then our fourth right there. Okay, so 4 lateral faces. And then we have our base. Okay, so total faces of a pyramid is 5. Okay, 4 of them are lateral. And then 1 is the base. Okay, so that is our more formalized definition or explanation of a pyramid. You know, one thing I want to explain before we do move on to the next part here is that what's very, very important was this point I had made over here, right here, the sense that it's not only these points along the edge of B, but also points in the middle of B. Okay, so this triangular region here, this rectangular region here, we are talking points all over that. Okay, so in a sense, what they're saying is that this rectangle, it says right here, this rectangular pyramid is as solid once the whole collection of points P have been connected to point V, the vertex, okay? Therefore, we need to emphasize the fact that this rectangular pyramid here is a solid, okay? It is not hollow, okay? You know, we draw them here, and when we draw them on these pages, they sure look hollow, okay? Because we show them like this, okay? Like this. We can see through them, we can see inside of them. So we kind of assume sometimes, incorrectly, okay, that they are hollow. You know, which makes your net, the net that you use to make the example or make a sample of a pyramid or any kind of rectangular prism or any kind of prism figure, it makes it you know, less useful than a true solid, because these are three-dimensional solids we are meant to be working with. Okay, so just keep that in mind. Okay, especially in the sense that we're going to be slicing these things. Okay, slicing these solids like slicing a solid loaf of bread or slicing a solid salami. Okay. All right. So here it says, now it continues on. If the vertex lies on the line perpendicular to the base at its center, okay, the intersection of the rectangle's diagonals, okay, if that is the case, the pyramid is called a right rectangular prism, okay, right rectangular prism. So the example of the rectangular pyramid above, okay, is not a right rectangular pyramid as evidenced in this image. The perpendicular from V does not meet at the intersection of the diagonals on a rectangular base B, okay? So right here, if we make our diagonals here, what that's going to find for us is going to find us our center point. Now this V, a straight line down, needs to actually intersect right there at that center point for it to be a right rectangular prism. Okay, now the ones that you made with the nets that were provided, they are indeed, and they do indeed make right rectangular prisms, because they do fill that requirement. Okay, the requirement that that point V, the vertex there, needs to have a line perpendicular to the base right in the center, okay, right in the center point, all right? Now this one here, which would probably look a lot like the one that you have, those nets, this is an example of a right rectangular pyramid. The opposite lateral faces are identical isosceles triangles, okay? In the case, this would not be the case here, okay? But you can see there's a straight line from V, vertex V, down to the base B, lands right at the center, or the intersection of the two diagonals, the base diagonals, okay? All right, so here we go. Let's go ahead here. You're going to use here, example 1, use the models you built. So hopefully you did build them. If you didn't, maybe you should go ahead and do that. That would help a lot. To assist in a sketch of a pyramid. Okay? Though you are sketching from a model that is opaque, use dotted lines to represent the edges that cannot be seen from your perspective, okay? So you can go ahead and do that, draw a sketch there in your, in your binder. You could use any of the pictures that I've produced on here as well. So go ahead and sketch yourself a pyramid. And this can be challenging, okay? Challenging indeed. So go ahead and give it a whirl and come on back. Okay, so, because visualizing slices made to a pyramid can be challenging, okay, I'm just going to go ahead and ask you here to, we're going to build up to it by having you do some sketching from different perspectives, okay? You know what different perspectives are? Different points of view, okay? So firstly here, example 2, and you're going to sketch a right rectangular pyramid from 3 vantage points, okay? So from directly up over the vertex, okay? So what would it look like directly over the vertex, okay? So think about that and go ahead and create something that you think. And again, use lines to to stand for your edges, okay? For all edges. All right, so go ahead and do that. A right rectangular prism from directly over the vertex. What would it look like? And again, you can look at if you have your nets built, you can just look over it and draw what you see. Okay, so hopefully yours looked something like that. Okay, yeah, and again, it's hard to imagine. You need a little, if we're going to be really artistic about this. We would probably want to shade a little bit to get that sense of depth here. Maybe we're going to shade this side, okay, and this side here. I don't know. Maybe you more artistic types out there. You might have gone that route to maybe kind of suggest some sort of three dimensions there. Okay, but as you can see, here's our vertex right here. Okay, this is the top. And we're going down to the base, down to the base, down to the base, down to the base. And we can see we've created 3 isosceles triangles right here. Okay, so 4 different triangles, of course. 1, 2, 3, 4. 4 different isosceles triangles. And then we have our base underneath. Okay. So again, this can be a little bit difficult. It can be a little bit confusing. Can be a little maybe a little bit stressful. But hopefully not, because this is not to be stressed over. This is just a lot of really, really good practice, okay? Now this next one, go ahead and sketch a right rectangular pyramid from facing straight on to a lateral face. So you have maybe you have your model there, your net that you made into your pyramid. Just take a look at it straight ahead, straight on, and draw what that looks like. All right, well in this case, you may have drawn something like that. Okay, looking straight at it, you can still see maybe a little bit of the two lateral faces that sit on the side, or maybe not. Maybe it just looked more or less like that. Just if you looked at it exactly dead on, you might have just seen the one face itself without seeing anything else. Okay. All right. So finally, we're going to have here. You're going to draw this right rectangular prism from the bottom of the pyramid. So go ahead and draw that. And that, of course, was probably the easiest one, because if you just flip that over and looked at your pyramid from the bottom, you would, of course, just see a rectangle, okay? And there's your rectangle, and that's the bottom, all right? So hopefully, as you look at these perspectives, you can imagine now a plane, slicing through this pyramid there, or slicing through it there, or even slicing through it here, okay? A little bit different, okay? You'll see what will be created when I lop this piece off right here. Well, it's pretty obvious, don't you think? Okay. Well, anyway, let's go ahead and take a look at the next exercise. Okay, so here, assume the following figure right there, okay, is a top-down view of a rectangular pyramid, okay? So this is just like the top-down view we made right before this. Make a reasonable sketch of any two adjacent lateral faces, okay? So here's a lateral face, and this lateral face is adjacent to it, okay? So you're going to go ahead and make any reasonable sketch of those two, okay, what they would look like, okay, side by side there. What measurements, and this is the key here, is what measurements must be the same between the two lateral faces, okay? Between this face, for example, and this face. What measurement must be the same, okay? Go ahead and mark those equal measurements on your sketches, okay, using tick marks, all right, which hopefully is going to give you a little bit of a hint, okay, and then justify the reasoning for your choice of equal measurements, okay. So go ahead and give that a whirl, and again, you're just go ahead and draw your sketches down here and mark where they should be equal, okay, where these measurements must be the same between the two lateral faces. Okay, let's take a look at this. Hopefully you notice that now this right rectangular prism is not necessarily does not necessarily have three identical triangles. Okay, I'm thinking that that one might have looked like that longer one would be that side, and the other one's kind of wider. Okay, this kind of fits with, of course, the idea that you have a rectangular base. Okay. And again, not a square base, but a rectangular base. Rectangular, of course, a square is a rectangle, but we're talking more or less rectangular here. And you can see that this picture here drawn is a rectangle and not a square. Okay. Anyway, the measurements that would be the same would be the sides. Okay, would be the sides. All right, they are all going to be the same length. Okay. On a right rectangular prism, they're meeting at this vertex. What will not be necessarily the same is the height of these here. Okay, the height is not necessarily going to be the same, but the length is going to be the same. So now these triangles themselves that we've made out of the lateral faces of this right rectangular pyramid are not necessarily going to be the same height, okay, once we take them out of the right rectangular pyramid. Now, of course, the pyramid itself is going to have a height, and that's measured right at the vertex down to the middle, the center point of the base, okay? All right? All right, well, here's example 4, okay, and before we do go on here, the types of slices taken in lesson, we've sliced parallel to a face and slices perpendicular to a face. In this lesson, we're going to examine slices made parallel and perpendicular to the rectangular base of the pyramid. Okay, so everything is going to be in relation to the base. Okay, and of course, that's our base right there, for example. Okay? All right, so a slicing plane passes through segment A parallel to the base B of the right rectangular pyramid below. Okay, right there. So what you're going to do is sketch what the slice will look like into the figure. Okay, so you're going to go ahead and sketch it into the figure. Then go ahead and sketch the resulting slice as a two-dimensional figure. Okay? You may choose, students may choose, how to represent the slice. You could draw a 2D or 3D sketch or describing the slice in words if you'd like to. Okay? But yeah, so go ahead on the figure, draw that slice, what it's going to look like, okay? And then just draw it over here to the side, what you think it'll look like. All right? Okay, so here's what I did. Try to do as good a job as I could there, making my lines, all right? Because you have to just imagine where your, imagine where your lateral faces are. There's one, of course, right here. Okay, that one that we had right there. There's a lateral face right next to it, and then there's this other lateral face behind that one, and then on the side there. So again, you're going to have four lateral faces. Therefore, you're going to have four lines drawn there to create this plane as it slices in the middle. And then, of course, if you just go ahead and draw that picture, that's what it looks like. And B asks you here, what shape does the slice make? Okay, down here, what shape does the slice make? And what is the relationship between the slice and the rectangular base of the pyramid? Well, of course, we can see the slice is actually just a smaller rectangle, okay? And there's most likely, rectangle, spell right here, smaller rectangle, okay? That's the shape it is. And there's probably a point somewhere along this pyramid where this shape would be a square. This one looks pretty darn square itself, but there's probably one point at least that, or maybe it's just one point, where all sides are equal, okay? But anyway, that's the relationship. It's just a smaller rectangle, okay? And you can see that any slice that is made parallel to the base, oops, that's really not very well done, okay? Any slice that's made, and that's really wrong too, but anyway, is going to be, it's going to create a rectangle. Okay, so here, a slice is to be made along segment A, perpendicular to base B of the right rectangular pyramid below. Okay? And now question A here asks us, which of the following figures shows the correct slice? Okay, so which of the following figures here shows the correct slice? So justify each of the following figures, why each of the following figures is or is not a correct diagram of the slice. Okay, so again, a slice is to be made along segment A, perpendicular to the base, B, of the right rectangular pyramid below. Okay? Which one is the correct slice? And then over here, why or why not either one is or is not. Okay, so let's take a look at each of these, and that's this one, of course. All right, so the first one here is not a slice by a plane, okay? Because there is a space. Now it is perpendicular, okay? It looks very much perpendicular. We could tell it was absolutely perpendicular if we had some right angle marks right there. That'd be better. But it is not, because now it is indeed a plane, okay? A rectangular plane that's moving downwards like this, okay? And it could indeed slice a section off there, okay, in that sense, and in the middle part, but it does not connect at the lateral faces. If you notice right here, there is a space right in between there, okay? So that plane does not extend to the lateral faces, therefore it is not going to fit our criteria. Now the second one down here also is not a plane perpendicular to the base, because the marked rectangular region is in the same plane as the lateral face in which it lies. Okay, so here's this lateral face there. This is actually in the same plane as that lateral face, And we know that those lateral faces are not straight up and down, and are not indeed, of course, are not perpendicular to the base of our rectangular prism, right rectangular prism. Okay, we know they're not. Therefore, anything that's lying in the same plane also will not be perpendicular to the base. Okay, this one is correct. Okay, it is correct, and the reason it is correct, and the reason it does fit our criteria, okay, because it does slice this plane correctly, because you can see that it is actually reaching all the way to the lateral faces there, two lateral faces there, and it is therefore moving downwards. We can tell that it's moving downwards, and it's going to be moving across that way as well. Okay, so it reaches all the way, and this will create a slice of that perfect little slice of this right rectangular prism. You know, something I would highly recommend you do in order to make this make a little bit more sense for you is to find some Play-Doh or some clay in the house, or make some Play-Doh or whatever, and make yourself a little right rectangular pyramid, okay, like this one right here, as you can see. And then go ahead and play with it and take some, hopefully you guys you floss, okay, you floss your teeth. Yeah, probably most of you don't on a regular basis. That's just a fact. I'm pretty good, but not very, very good. My wife is excellent. That's why she has such perfect teeth. Anyway, what you can do with that dental floss is really fun, is that you can take that dental floss and just kind of, so if you hold a piece up here, for example, then you can pull it down, okay, and you can make a nice perpendicular slice right down there. You kind of cut this thing right in half, or you could take it on the side and then pull it through that way, okay, and you can pull it through diagonally, whatever. It's a really, really fun way. If we were in the class, I would absolutely have you guys doing this, because again, it gives you a really, really, really good flavor and feeling for what you are doing. We're kind of doing this on paper. We're doing this with three-dimensional drawings on a two-dimensional surface, which is never the same, okay, as actually working with a three-dimensional figure. So if you would, I really, really highly recommend that. Okay, so yeah, just a little tip as how to get to know these things a little bit more intimately. Okay, so here we are finally here. A slice is taken through the vertex of the pyramid perpendicular to the base. Sketch what the slice will look like into the figure, and then sketch the resulting slice itself as a two-dimensional figure. Okay, and this would be a fun one to do with clay, just like we talked about just now, or Play-Doh. Play-Doh might be a little bit neater. Anyway, yeah, so go ahead and do that, and do the sketching here, and yeah, and come on back. I think you're going to breeze through this one. Okay, well, there you go. There is the triangle I drew. And again, this, well, not again. Why do I always say again? I never even say it yet. But anyway, this line right here, this side here should be tucked up right against that. It's not perfect. Anywho, fill that in. There is my slice. My plane has sliced through there. And it's, of course, created the two-dimensional figure, which, of course, is a triangle. Okay. Well, there we go. That's it for this lesson. Here's our lesson summary. A rectangular pyramid differs from a right rectangular pyramid because the vertex of a right rectangular pyramid lies on the perpendicular to the base at its center, whereas a pyramid that is not a right rectangular pyramid will have a vertex that is not on the line perpendicular to the base at its center. And of course, at its center is the key term, at its center, okay? The right rectangular prism is going to have the vertex is going to meet that base right at its center point. Okay, its center point. All right, so slices made parallel to the base of a right rectangular pyramid are scale drawings of the rectangular base of the pyramid. Remember that idea of scale drawings, okay? They're either larger or they are, well, I'm sorry, it can't be larger, but they are smaller. They will be smaller, okay? So if we keep cutting slices out this way, parallel to the base, we are going to be creating rectangle after rectangle after rectangle. In this case, moving this way, getting smaller and smaller, but still maintaining the same ratio, okay, or the same proportion. They are going to be proportionally the same, okay, all right, or I should say identical, huh? Identical, okay, and that's probably going to come up in a little bit. So anyway, there you go. That's it. Again, under 40 minutes. Yay to me. Go ahead and get those problem sets done, and see you lesson 18.